All right, here is section 4.5, which is learning how to graph logs. And we've already seen how to graph exponentials. So we'll take a look at this kind of sheet to walk us through. So first of all, we've got a basic log, looks like this. And then we've got it going through the point 1, 0, or b, 1 up there. So we've got these 2 points that kind of go on them all. And then the inverse, sorry, not the inverse, the -1 is down there. So what that means is if your base is greater than 1, so if I have log 2 of x or log 3 of x, and this is if your base is a fraction less than 1, so log half of x, etc. Okay, so basically you want to put this in your toolkit functions and know where they basically go through, know the basic gist. They go through the point 1, 0, b, 1, which is your base, so forth, right? So those 2 points are the same for both, kind of helps you figure out what you're doing. So on this, your domain is 0 to infinity. You can't put negatives in a log, which means this x component cannot be negative. And then the range is all real numbers. Something to consider, unless you shift it, there is no y-intercept because it does not actually touch that line. Now, shifting could give you a y-intercept, but the basic one does not have one. So here's our different transformations. So with any of our other functions, if you have an f of x and you add some number out here, the plus c and the minus c in this case, it shifts your graph up and down. So if I'm going to put a positive c plus 2, it's going to shift all of it up 2. So those key points we had up here are going to be shifted up 2 units. Same as if we had a minus, so that would shift it down. So it would move this piece down if we went minus, for example, and have everything still look the same. It still wouldn't have a y-intercept. It would still not hit this y-axis, despite my previous drawing. The horizontal shift. So when we were working with quadratics and cubics and all, we had this number in here, squared, cubed, whatnot, and we knew that it moved it the opposite direction horizontally. Still does that. So if you add a number in there, it shifts it to the left. If you subtract a number in there, it shifts it to the right. Okay. So that's where we might actually end up having a y-intercept, but it's not something we would normally worry about. So if I shifted it over to, it's now going to go through the y-axis. And this now becomes over here. So you're shifting that asymptote line. All right, reflection works the same way. If you put the negative on the outside of the whole thing, it's the x-axis. If you put it inside, it's the y-axis. So we could flip it over the x, or we could go over and flip it over the y, which I've just run out of room for, but we can show a few of those in a bit. And then we've got this idea of vertical shrinking or stretching is that number in front of the log. Okay, so just like if you had 1/2 x squared, instead of being looking like that, it gets a little wider, does the same thing with logs. So it stretches it. If that c is greater than 1, it shrinks it or flattens it out a little more if it's between 0 and 1. Okay, so now I have this sketch the graph and I've switched over to the PowerPoint now. So your normal log goes through right here. And then it goes up, nice and pretty, da 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 da. So what this is going to do is remember that x plus c moves you to the left 2 units. So a good way to look at this is move that that vertical asymptote over 2 units, and that's now where everything's going to hit. So before it was going through 1, 0, and it had that horizontal or vertical. I'm so sorry, I keep saying the wrong thing. Now we're going to shift that 1, 2. So this is now our vertical asymptote, and that point here gets shifted 1, 2 over to there. So we are left with this one, which is shifted 2 units to the left. Okay, and use that vertical asymptote as a nice frame of reference. Okay. All right, so for this next one, I already have the answer here, but we're going to look at how we can get there. So it does a couple things. So I'm going to go in order, but the order you go in is completely up to you. So the first thing I'm going to address is this guy. So our normal log looks just like this. Okay, let me clear that. That looks terrible. So our normal log function looks like that. It's got this asymptote here, and then this is 1, 0. Okay. So what this does is it reflects it about the y. So remember, inside is the y. So we're going to bring it over to this one. Okay. So now this point of reference is -1, 0, because we've made the x negative. Now another part to look at in here, though, is that negative comes out, and inside of here is really x -2 when we're doing our reflection. Because it's been flipped, that's what it's going to end up looking like. So that's part 2, is we're now going to take this graph, which was right here at -1, 0, and we're going to move it over 1, 2 units. So now I have this guy. So we're back at 1, 0, and our asymptote line is now 2. Last piece we're going to address, I'll get a different color, is this 5. So what the 5 does is it now stretches it up. So before it was going through that point, you know, it was going like this, and now we would stretch it so that it hits at that 5 point now, and just takes a lot longer. So we're still looking at this 1, 0. We've still got that asymptote line, and we're stretching it up. Okay, and that's my finished example there. Okay, so then we're going to go the other way, and we're going to find the equation of the logarithmic function that is graphed. I don't know why that guy's at the bottom there, but we're going to ignore it for a second. Okay, so first of all, a normal log goes through right like this. Okay, has this line as its asymptote. So we're going to look at that. So this one is already shifted over because the asymptote line is over here. So it is already shifted into x plus 2. And again, use that vertical asymptote line to help. And the order you do these is really up to you. What else are we noticing? It's reflected. And it's reflected about the x-axis. So it's going this way, and it's flipped across to look like that. So that's going to put the negative a here, and then we'll have our log. And then our point is also moved up 1. So we're going to end up having a +1 on the end. So I'm going to erase all this for a second and figure out what we have. So to start with, we have a negative a. And that was our reflection about x-axis. Okay. Then we have the regular log function, which we know it's a log because we're looking at the shape of it. So I've got a log, and it's going to have some type of x, and then we're looking at any shifts. So we're going to bring in the +2 in blue, because it's shifted 2 units to the left. Sorry if this is not looking as pretty. And then my last one is we're putting a +1 out here because it's actually shifted up 1. All right, so now we can keep going. We need to use any coordinate we can find on here that we know goes in it. So we're going to use the coordinate pair 2, comma, -1 to find A. Okay. And then when you do that, that's how you come up with this nice answer down here, which showed up originally but wasn't supposed to. So what happens is you end up with the log, and when you're solving for it, that whole piece, that A, becomes this guy. And if you're not sure, look for a couple more examples where we can work on that one a little more. All right, so then the next question is domain. And then I have another one here, so you can go ahead and check and see if you're getting them. Domain of logarithmic functions. What's the rule with domain of logs? The rule is you can't be negative. So this 5 minus 2 to the x has to be greater than 0. Now, if you're not sure if you can do 0, on your calculator, click log of 0 real quick, and it tells you domain error because it has to be greater than 0. So if I want the domain here, it's 5 minus 2x must be greater than 0, and then move everything around. So -2x greater than -5, -2. So that gives me x, flip the sign, is less than 5/2. So you should now be able to check your work. I'm a big fan of checking your work. Put in a 3 here. So on your calculator, type log of 5 minus 2 times 3, and you should get an answer. Less than. Oh my gosh, I'm sorry. Put a 1 in there. If you put a 3, if you forgot to flip the sign, you get a domain error, which is fantastic. If you put a 1 in there, you actually get a number. So it just depends if you're not sure if you've done it right. I always say check your work. All right, and then finally, this last one. It appears my screen is frozen. Okay, I think that's it for me.